Welcome to Builder Buzz by Home Nation, where we bring in builders, developers, and everyday investors to talk about one of America's biggest opportunities, affordable housing. We'll talk about real costs, explosive growth, big mistakes, and tough lessons you won't learn anywhere else. Whether you're building homes, buying land, or just building big ideas, this podcast is for you.
Hello, everyone. Rechargeable buildings. Have you heard of that concept before? Probably not. It should bring to mind, though, environmentally conscious sort of ideas. Specifically, our guest on the show today is Jack Laken, and he's with TermoBuild. It's his company that he started. And rechargeable buildings has to do with heating and cooling. It's essentially doing more with less, taking existing engineering, existing components, and using that in such a way where you're able to heat and cool your home through the concrete floor in a way that's going to save you money, and it's going to be less engineering, and it's going to be better for the environment overall. This is a brand new concept that his company that he started is doing. It's new to the US, it's new to the world. No one else has been doing it before, and it solves a lot of problems and just really leans into the environmentally conscious mindset and solving things in a new way that others just haven't seen. The solution's kind of been there the whole time. Jack has a history in engineering. He's done it for decades, and he set out on his own to say, hey, let's provide the solution here that everyone's really looking for. You're going to learn a lot on this one, finding out what rechargeable buildings means. Jack's got a ton of knowledge on this subject, so tune in. It's going to be great.
Sure. So my name is Jack Laken. I am the CEO of TermoBuild company that is driving rechargeable building systems. What we do is we use regular concrete to enable it as a rechargeable battery that can store heating or cooling, as well as deliver radiant heating or cooling at the same time because the floors radiate.
Mm-hmm. Mm-hmm. So I looked a little bit online and was trying to understand with that like flooring concept, and it looks like this is something you can do for new construction or for existing construction. But can you just describe a little bit more of the mechanics of it?
Right. So basically what we are doing is usually we link the rechargeable floor, which is kind of a ventilated floor, that links with a much smaller heating cooling system. What's interesting about it is that really we're not introducing new technology. We're just linking two well-known products or commodities together to deliver much better outcomes. And that is kind of the essence of the technology. And predominantly what's happening is the homes or buildings are charged at night. And so the cycle is very simple: charge, store, release during the day when it's needed. So this approach actually introduces really a holistic regenerative building approach.
So, all right, so tell me, maybe I missed it. Tell me a little bit more of the mechanics of it, how you charge the building at night.
So because the floor is a ventilated floor, so we basically, let's say, so at night in a summer mode, we have a lot of chiller-like nights. Like in California, they have up to 7 months of the year, 55 degrees Fahrenheit temperatures at night. Yeah. So they can actually, by using ventilation, they can actually supercharge the floor with cooling for the next day without mechanical systems. What's interesting, it's actually cleansing the building at the same time, because you see the indoor air pollution occasionally can be more polluted than outside.
So when you say ventilated system, how do you do that? What does that mean? Just help me with that.
So there are two approaches. One is before we, let's say, pour a concrete floor, we create a small, let's say 5-inch in residential or 6-inch branch ducts embedded in the
Yeah.
concrete floor, and it's poured. So it's done in such a way that it efficiently is absorbing the energy. If we actually bringing in, for example, 55-degree temperature air, which is free or from the air conditioning system, on one end, from the open air diffuser on the other end, we get 69, 60, 69, 70 degrees coming out on the other end. The rest of the energy is absorbed by the slab and it radiates into the space, or by the floor and radiates in the space.
Oh, see, that was what I was kind of curious about, because ductwork doesn't, I mean, that's not a lot of air to hold inside of it. So you're pretty quickly going to diffuse all of that air into the open space of the house. So I'm like, well, how do you keep it cold?
Absolutely. So we kind of create a bit of a vortex inside of that labyrinth, so that is where, when we are able to, let's say, as I said, to pick up on the input 55 Fahrenheit, and on the open air diffuser, you get, say, 69, 70 degrees Fahrenheit. So that is an interesting approach, and it's not done typically. And these rechargeable buildings, let's say, or homes in the master plan community, they can become energy sharing homes, because all of a sudden, we don't need, first of all, we benefit from nighttime discount on energy, which the utilities offer. So right now we can, or what do they suggest, charge an electrical car. But if you don't have it, then you can do laundry at night. But that's basically how much you can do. So we're saying, instead of charging a car, which we may or may not even have, why not to charge the whole building? And what we find is this approach leads to buildings or homes that can basically become zero energy bills, homes with zero energy bills. Or if we add a little bit of solar, which is less than normally suggested, we basically can be net positive. It means we can produce more energy that we can consume. And we have examples of these buildings, that are validated by utility meters, not by opinions, just utility meters.
That's good. So typically when I think, maybe it's just me, okay, but typically when I think of energy saving sort of things, I think of more expensive. Kind of like when you think of, well, you got to eat healthy, eat organic. Well, great. Well, organic food's more expensive. But this sounds like a really simple system. This doesn't sound like it's very expensive.
This is it. Exactly. What it is, I'll give you a little bit of a background where I'm coming from. I used to own a mid-sized consulting engineering company that was designing everything that goes inside of the buildings. And we completed millions of square feet of buildings of all kinds, small, big, national, international corporations, so on. I realized that we as engineers are really trained to support manufactured solutions, and that's why your feedback by saying that better buildings should cost more was kind of puzzling and troubling me a little bit, or maybe a little bit more than that. So I quit doing conventional, and we integrated. We basically felt that integrating two well-known commodities, let's say the air conditioning of your choice, we don't influence even the choice. If you like heat pump, it's fine, which basically now it's fashionable, but you can use a regular furnace and a regular air conditioner, and you can get radiant comfort. So we actually developed software and recalibrated, that typically conventional engineers do not have. And we have done buildings, in Canada, we've done in the United States. Canada, more like it's a colder climate. United States, we had it in South Carolina, which basically it's hot and humid. And we even did projects in India, where basically they have their own issues there.
India?
Yes.
It's very hot in India.
Well, it's
very
hot,
humid.
But the issue is not about the heat.
Okay.
The issue is about how stable the energy grid is.
Yeah.
So during the day, believe it or not, it was going up and down more often than the stock market in New York. It was not stable. Blackouts, brownouts. But at night, it was relatively stable.
Yeah.
And what's interesting is the energy grid. Actually, the reason they give discount on energy is because the need for energy at night is low. compared to daytime, where basically sometimes they even struggle and they need to put additional peaker power plants to support the very high demand. So what's interesting is at night when we were doing the charging, first of all, it's cheaper because the temperatures are lower, and the whole thing kind of comes together really nice. To give you an example, in a colder climate, obviously, like the East Coast that we have, in Canada, United States, that is a fairly good approach. Buildings we charge it at night, are definitely more advantageous to do that, especially if, let's say, we have all electric building or electric house. But we can use, gas as well, which we basically have a lot of buildings that they use a combination of. But really, it's all about simplification. It's really a solution how to do more with less, and that's where we.
Yeah, doing more with less. That's where you are. Are there other companies that are doing things like this? Like this rechargeable building? I think it has a battery. I think was a phrase I saw. Are there other companies doing this, or this is just really what you are doing?
So we're the only ones. We're the only ones in North America that are doing that.
Why?
As I said. Pardon me?
Why?
That basically dials back to the fact that the engineering community and obviously architects to a lesser degree that design buildings are really have the tools to do that. You see, the best what can be done, let's say, with the green buildings today, those are the LEED building, LEED certified, yes? So to flush buildings at night. But flushing, it's not the same like charging or supercharging. And that is basically one of the drawbacks that when we were guiding PhD students in sustainability, they realized that the word thermal mass is well recognized by architects. But that's about it. And a lot of people are using the word thermal mass. So everybody can store energy, but how to benefit from it in a big way, nobody knows. So that's where, we kind of, I guess, ahead of the pack. And sometimes when they take out half of the equipment, engineers are not comfortable. So we guarantee what we do. And we have buildings that are listed best performing in both Canada and United States.
Wow. So the industry is just kind of catch on to this. And no one else is really even trying.
Yeah, it's a combination. You see, more with less. We're really kind of tripping up a bit of a food chain.
Yes.
So let's say if somebody wants to supply larger systems, now we say we need only half.
They don't
They don't like it. So we're kind of a bit of troublemakers in that space.
Troublemaker. Yeah, you come across as a bit of a troublemaker. You know enough to really cause some damage. Perceived damage, I should say, to someone else as far as what they think. So then, all right. So this geothermal heating and cooling, I feel like it's more popular for some reason. The country Iceland comes to mind, where they do stuff like this there, and maybe out in Europe and what have you. But like this idea, and you have like pipes that have hot water in them that go through the building during the day, or I don't know, things like that. That kind of relates to this, or are you like, no, not the solution? This is.
It relates to that. You're absolutely right. However, we don't need all this cost and complexity. We don't need pipes. We don't need hot water.
Yeah.
We basically can use regular equipment that we're putting in a building, especially in a house. Let's say if you have a gas-fired furnace or basically, or a regular air conditioning, all of a sudden can deliver radiant comfort and can deliver energy storage. So the homes or the buildings, they basically become like a hybrid car. Most of it is driven by harnessing that free energy that surrounds us. And that's where we are. So you're right. Iceland, they do. And in Europe, they do actually put in in-floor heating. But as far as radiant cooling, that becomes a little bit of a challenge because the system's a lot more expensive. And to control the radiant cooling becomes very difficult. Sometimes
Yeah.
they kind of create problems like um, sweating, condensation, and what have you. Air-driven don't do that.
So, all
The
right.
one that we
Yeah. Okay. So sorry to cut you off, Jack, but now I'm curious because you say that it's costly for cooling, but the way that you described the system, and maybe it was just a simple explanation, but it seemed like, man, this is really simple. It's just ductwork in the floor. Help me understand then. It doesn't sound costly with what you're doing, but it sounds super simple. So why haven't other people done it? And then is there the system that you could maybe explain?
So obviously, once it's set, there is nothing more to it.
Mm-hmm.
It's just basically linking two systems. The concrete floor, first of all, doesn't have, well, it's basically has the ability to store and release energy for as long as the concrete is there, like as a thermal battery.
Mm-hmm.
It's not disposable compared to, let's say, any others.
Yeah.
On the other hand, you see, what's happening is the proper understanding that we need about half of it, and we can leverage, free energy or kind of charge it at night where energy is at a huge discount. In some places, it's 49%. In Texas, could be up to 75% discount, and then even in Las Vegas, Nevada, at night you can get it at 70% discount at night,
Oh.
and nobody can do that. So it's really the precision engineering, setting up kind of a little bit more advanced control, which basically tells the building or the house at night.
Yeah.
And that command is not there. We usually say do night setback. That is a setback in
Mm-hmm.
our with our solution. Yes.
So then the actual mechanics themselves, it's got than just you put some ductwork in the floor.
Right. You see, the way it's set up, it actually creates an active thermal exchange. And that's why if you put a regular duct, as you mentioned, you're blowing air on one end, comes out on the other, not much is happening.
Yeah.
So we need to create
You said vortex?
vortex. Is correct.
Yeah, okay.
And what we are doing. So our labyrinth, it's not like straight ductwork. It's
Okay.
just kind of a labyrinth. On the other hand, we can use another product that is widely used in many places called precast concrete floors, which they already have holes in them, round holes.
Mm-hmm.
They're called hollow core floors. And and they're suitable for both residential and commercial, institutional installations. So we don't even need any branch ductwork to put in. We can just use the voids inside of the concrete to, again, in a modified labyrinth, to create that thermal active exchange. And that part is kind of missing from get others a feeling.
Getting involvement from
Right.
others. So there would
Yeah.
be some sort of access point or multiple access points from the foundation to the exterior, right? Some sort of vent.
Right. It's not any different like in any, let's say, house or building. Obviously, let's say in a house, for example, you may have a couple of vents in each one room, a couple in the other.
Yeah.
That's exactly what's happening there. So when you look at it, everything looks the same, except it feels better, operates better, and the equipment is smaller.
Okay, but I'm saying the air has to come from outside, and you're getting that into the foundation system. How?
Right. So you see, the heating cooling systems are set to bring fresh air anyway. You have a certain amount of fresh air. So that's basically that can be driven by the fresh air intake that we already have. But instead of engaging the heating or the cooling, we just use the ventilation only when it's advantageous. If we feel outside are not suitable, then basically we introduce heating or cooling to maintain the desired comfort.
Okay, so then what are nothing's right. Every system has limitations. What are some of the limitations with TermoBuild?
Yeah. Okay. So the limitations are pretty well dialed back to equipment that basically is chosen by, let's say, by the customer or suggested the engineers. So so that's basically what it's all about. And the concrete floors are, as I said, they have no wear, no tear in the thermal properties. If you want to change the flooring type from one to the other, that's fine. So there are no limitations there. So really, it's limited to the type of equipment and the warranties that the manufacturer provides.
Yeah. So, but what about like the second floor? If you're a two-story building, a single-family residence, it's not a concrete second floor. That flooring isn't.
So that's the point. So that's basically, we basically it would be nice to have floor for the second floor. So that brings up the issue of the cost and things like that.
Engineering for it.
Right. Engineering, yeah, to some extent, yes. But what's interesting is by introducing a concrete floor, we can have much larger spans. So it means that we don't need extra columns and beams if we use cross-laminated, wood joists or whatever, because as you kind of go beyond a certain span, they become a little more expensive. Then you need other things to add there to, In our case, we have to look at the total picture. Total picture is that we're getting basically from a regular, much smaller heating cooling system. We basically not only getting just comfort as comfort, but energy storage or resilience. We basically end up with warm or cool floors. Coincidentally, that radiant warm floors in United States are only showing up about 3% of the homes. Only 3% have it. And it's easy to verify, by dialing into artificial intelligence, asking how many homes have it. So it will be about 3%, somewhere there. Radiant cooling, it doesn't show up as a good number. And energy storage, not many are making ice at night, for air conditioning in a house. Or burying storage tanks. So altogether, that second floor, the cost it depends on the size of the house. In a luxury home or a bigger homes, the economics work out really good. In a smaller homes, it there is a break-even point somewhere where, there is a certain preference. But it leads to, radiant comfort leads to a better good night's sleep as well. So that's another interesting point. So it's health and wellness, to be considered.
So it sounds like I'm curious. You have an engineering background, right? For many, and then you decided enough of this. I'm going to go solve something that I'm seeing, and I'm going to change the perspective that people have because I think it's wrong. How, if you didn't have that engineering background, and let's just say you were like environmentally conscious as an individual and you wanted to I want to provide a solution and I want to have rechargeable homes, like that sounds like a cool idea, I want to go do that, and you jump headlong into it, do you think that you could have done it without your engineering background? Like, do you think you could have been successful?
That would be a little tricky. Because you kind of have to understand how to link different elements together in a way that they make music instead of noise. And that's what we basically are doing. So definitely the engineering background, however, being exposed to a variety of buildings in different climate zones and different clients' need kind of helped me to fast forward that approach and I guess become a little troublemaker in that area.
because you're not necessarily selling a product in the sense of you've created something new and there's this new HVAC system that works way better than the other ones and you gotta buy it. What you're selling is it's like kind of what you said, using the instruments that already exist and you're making harmony from the chaos. And you're saying, guys, there's a way that we can do things with what we currently have and it's going to be better. So you're selling an idea, and really it comes to as engineering probably, I would think. Like, you tell me the plan you want to build, I'm going to tell you how to do it this way. Would that be accurate? Is that how you go about it?
Right. Because a lot of buildings we developed obviously began doing it in Canada. buildings we could not participate if we are a single source supplier. So in a way, we have the capability because we're managing, heating, cooling, air conditioning, control systems. We were managing all that and really commissioning and pre-commissioning. What was interesting is we could not participate as a single source supplier. We can do a one-stop shop. We can deliver you a hybrid building, for example, because that's what we're doing. So I dialed back to basically providing strategic advice. It's engineers or facility planners if they are, or developers. And when they like what they see, and we guarantee what we do, so it worked out okay. But we have the capacity to kind of expand and say, okay, we do one-stop shop, but we do, the air conditioning and linked with the rechargeable floor. So you'll end up with a hybrid house or a hybrid building. It can be done as well. Working, let's say, on the other end of the continent, like in India, for example, when we did, we basically, we can't ship concrete. It's not a chocolate bar that we can send from let's say, New York to India, in Mumbai, Bombay, whatever that is.
Yeah. All right. So you said single source supplier. They wouldn't work with you if you were a single source supplier, so you had to dial back. What do you mean by that? What does supplier mean? What did dialing back look like?
So if we say, okay, we offer a solution, and here's one interesting example. In fact, we had a $500 million development, in a design build mode, where one of the top engineering companies in the world that were part of the iconic building in London, the X-shaped building that is kind of recognizable when you look at London. They were part of the team. It was $500 million development. And everybody loved it. The decision makers loved it. But because it was a public project, they would not. They had to change their bylaws to allow a single source supplier because nobody else could provide a competing solution. And that was a bit of a challenge. So basically, the project didn't go. Although it offered all the benefits, that the decision makers liked it, but the legal department said we cannot do it.
Why? Again, what's the problem with a single source supplier, like a one-stop shop? Is that what that means?
Right.
So why is that a problem?
So it means that no other competing competitors can bid on it. Although the competitors there, like you mentioned, Iceland, for example, they make this tubing, piping, plumbing, pumping that they put in the floors. They could have competed, but because we don't need that, we could save about $40 to $50 a square foot in today's dollars. So we would beat them hands down, but they didn't feel it's the same. So, but I guess in the United States, it's quite different.
Yeah. And
when we offer a value proposition, that could be a lot more receptive.
Yeah, I mean, it sounds like to me, that sounds like a mistake to stop something that everybody wants, and it seems sense,
Yeah, absolutely. I agree with you. And everybody was kind of, we had a very powerful team. And, the engineers were like world class. It's probably number one and number two engineering company in the world. That basically said, we love it. It makes a lot of sense. And in fact, it would have been kind of, would fit into smart city initiatives to do that.
All right. Well, that opportunity, that is what it is. It sounds like you dialed back and changed what you're doing. So then where are you at right now, and what do you see there being for TermoBuild?
So we basically continue to promote what we're doing. And, when we kind of get into a face-to-face conversation with decision makers, they like what they see. And that's how we basically get the traction. But, to be in more places at the same time, we need a little bit more kind of interaction face-to-face.
Yeah.
So we really, would welcome interested parties to collaborate with us, and we're happy to share and make sure that we're good.
To get your name out there, so people recognize, because it's new. Part of your trouble is not the validity of the product; it's just getting people. It's out there.
That's it. Because you see, when we say we need only half of it, that becomes a little bit of a challenge, even to some engineers, no fault of theirs, because their tools, the software that they use, tell them put in twice as much.
Correct. Yeah.
And
yeah. Just doesn't compute.
So, well, this is it. But we continue doing. We're making progress. As I said, we have buildings guide to net by the Department of Energy, National Renewable Energy Labs. At that time, and I believe it may remain even now, the largest net positive development in United States. It was 678,000 square feet.
Which was this?
It was a portfolio of educational buildings in South Carolina.
I think I read was one of the case studies. I was reading about that. Yeah.
Right.
Yeah.
And so it's very interesting. So as I said, it has been tested in different climate zones and everything else. It could be suitable for master plan communities because they really can actually propel with health and wellness, and we can use basically the regular building techniques or manufactured housing, and basically include that rechargeable part, and all of a sudden they can cater to a number of different markets, and now this regenerative, let's say, construction or regenerative housing becomes very interesting thing, because a lot of the Z generation and the baby boomer generation and few in between, they basically health conscious. So and eating healthy and sleeping in a toxic house is not always helpful, because a lot of research shows that many of the homes, indoor air pollution is higher than the outdoor air pollution, because of the all kind of gassing and cleaning and what have you that takes place.
Okay, so I don't want to take too much of your time here, but I'm curious, is there any sort of system or process for retrofitting a home, an existing home, for it to be rechargeable, or is it like, hey, this has to be done when the foundation's poured?
Right. So in the homes, I would say it would be driven by the cost and benefit analysis. Some could be suitable, some not. So it's not a magic bullet. To do that. Some retrofits could be very successful. Some not so much.
Yeah. Okay. All right. So if someone's interested, because they say they want to know, hey, can this work for my house? Are there like some guidelines, or is it a case by case basis? What would they need to do if they're interested?
So the guidelines, basically, we want to know basically what's their preference for heating, cooling equipment. Tell them that their equipment can deliver, a lot more than they basically expect now.
Yeah. Okay. And then if someone's interested in doing this for new construction, what should they do?
If they get in touch with us, we'll tell them very quickly. We'll make an initial assessment, a free assessment, telling them the difference that could make a big difference.
Sorry, no, you're fine. Go ahead.
Oh, no.
Okay.
Basically, we need to assess what exactly they are planning to do, and we show them how much better they can do. In fact, they may be even eligible. Like, we're not counting on any grants, taxes, or incentives.
But they might.
But they could be.
Yeah.
None of our buildings, the government or whatever, it's just basically you end up with better buildings.
Yeah. You're not reliant on that. Like, your success is simply, it's visible through what you're providing. You don't rely on the handouts to be successful. Your product and your idea stands on its own. Well,
they do, and people basically that use our approach, they definitely, they benefit from it in more than one way.
All right, so last question here, just curious, TermoBuild, is that an engineering, like, play on words? Why the name TermoBuild?
TermoBuild is basically that it refers to thermally charged buildings. So we didn't want to create like a long explainer headline. And so same like you asked, what is TermoBuild? Well, it's a hybrid building, really.
Yeah. And
Maybe we should add the word hybrid
no,
TermoBuild
no,
as a hybrid building.
no, I get it. I like, like the rechargeable buildings. That concept really sticks in. It just really sticks in my head when I hear it. Like rechargeable building. Okay, that's a phrase that I hear often, but it communicates something. And if you don't understand it, it's like, man, I'm curious to find out, like, what does that mean? So that's a great phrase. And the name
Right.
ThermoBuild communicates as well. It's environmental. It's geothermal. It's energy, right?
Right. So what's interesting, basically, we can't treat the building as an appliance. That actually dials in,
Yeah,
almost like a smartphone. You see, with Wi-Fi enabled, basically they make a handshake with the energy grid. So instead of being like a consumer that I need energy when I need it, basically kind of do it in a mindful way that we basically use energy when many don't need it. So during the day, it avoids and releases the spare for those that need.
yeah,
So that becomes a very interesting AI enabled, let's say, even if it's a master plan community,
mm-hmm,
it can benefit from the energy sharing.
yeah,
Let's say if we drop during the peak hours for 3, 4, 5
yeah,
hours, nobody will notice the
yeah,
discomfort.
yeah. That's really good. Well, I appreciate your time, Jack. A couple phrases that really stood out to me: rechargeable buildings. The home, it breathes. There's one like a hybrid car kind of that.
Absolutely.
Those are all phrases that really stuck to me and communicate pretty clearly. All right, this is what you guys do. This makes sense. So because it's a new concept, and so I'm putting it together in my head. Okay, what is this? How does this work? And that helps me understand it.
Yeah. In closing, I would like to mention spectacular failure during the Olympics in Paris of last year, where they created environmentally friendly air conditioning. They used there all this piping and what have you. And what happened is when the U.S. team made an assessment,
Yeah,
they basically said that we better bring in our own air conditioning, and that's what they did.
really.
The problem is not that, let's say, the U.S. team was particularly kind of sensitive about increased air conditioning. The problem is that at night they had chiller-like temperatures, 55 Fahrenheit, and during the day it was not going over 90. So if they were to use the ventilation fan and our technology,
Done.
they would avoid it. They avoided Olympic-style embarrassment.
Yeah. Yeah. I didn't know this. I didn't know
Yes.
this. Wow.
You can check it. On the internet, you'll find it. Olympic team had to bring in their own air conditioning for Paris Olympics.
Wow. And so do you think now I'll look it up. But that was because the Olympic Paris, they just didn't set things up the right way?
They set it up according to the green guidelines that they have, but their green guidelines are influenced by manufacturers. They basically spend a lot of money, which basically
to do a lot of nothing.
Here you go.
Wow. So it sounds like you need to get in touch with Trump for the LA Olympics. That's what you need to do.
Well, yeah, because I'll tell you, they have up to 7 months of chiller-like temperatures at night.
Exactly.
So they can use the same principle, absolutely the same principle. And in fact, to rebuild the Palisades, these 15 or 14,000 structures, this housing, it can become an exemplary, rechargeable, climate smart that can share energy between and use very little energy during the day. And they can become zero energy homes without any problems.
Yeah.
Because they would need very little supplementary solar.
Yeah. And California would be the place to do that. They would be all over it. Yeah, they're much more leaned into that sort of environmentally conscious building. So
so far we're still talking. But the question is, from to doing, it could be, a little bit of a gap that needs to be
how
bridged.
to get there. Yeah. Well, I'm sure you will, and this is part of it. Getting your information out there, getting the name out there, the concept out there. Yeah, that's part of it. Well, thank you, Jack. I really have enjoyed this conversation. Thank you very much.
Yeah, my pleasure. And yeah, I really enjoyed as well because you have great questions, and it's a pleasure kind of navigate through
Yeah,
any question that you had,
yeah,
and perhaps many others may.
yeah. Yes, absolutely. We'll put this out, and I may follow up with you in maybe 6 to 12 months. We may have you on again and just see how things are going.
Sure. Actually, I have some links to videos on different subjects
Yeah,
that I'm happy to share if you choose so,
for sure.
if you like.
Yeah. We can put things in the description, and then people want some learning on their own. TermoBuild.com. There's a ton of info there. Lots of different building types, how you guys work, the services that you do. The website's pretty comprehensive. It looks like so. Great resource there for anyone who's interested in looking and doing their own research.
Right.
Yeah.
So, and if we get some good traction, what have you, so instead of sending you a concrete floor, we'll send you a chocolate bar.
Thank you, Jack. Really enjoyed it today. Thank you so much.
Thank you.
Yes.
Okay, bye.
Bye.